Okay, guys, this is a continuation of our lecture for 11.1. Okay, in the last lecture, we just started talking about like different hypotheses and kind of like the thinking behind statistical tests or significance tests, also called hypothesis tests. This is kind of where we left off. Okay, so you gather your sample evidence, your sample, statistics, and you take a look at it and then you calculate a p-value, then you compare this p-value to some threshold value. And this p-value will immediately illuminate to you a decision whether to reject H null or fail to reject H null. Okay, so if you get a very, very small p-value, you're going to lean towards rejecting the claim of no difference. Okay, if you get a fairly large p-value, you're not going to accept the null hypothesis. You never accept it, and you never say that it proves the null hypothesis. Okay, all you do is that you fail to reject. So you're not accepting it, you're not proving anything, you're just failing to reject. Okay, so p-value is small, reject H null. Okay, and then what do? We conclude that HA in context is probably, there's probably evidence for HA in context. If the p-value is large, we fail to reject H null, and then we cannot conclude HA, okay, in context. And I'll go over this more when I do a video on, or when I teach you guys procedures, because this is the conclusion part of the procedures. Okay. So if we do get a small p-value, okay, p-value is less than some what we call alpha level. Alpha level is the threshold value. Okay, it's the threshold value which determines whether we're going to reject or fail to reject the null hypothesis. Okay, there is no one set alpha level that fits every circumstance. Okay, alpha level, it just depends on like what scenario you're in, right? If you are like engineering space shuttles and your tolerances are extremely tight and you're doing some kind of significance test, you might have a very, very small alpha level. You might have a very tight tolerance, right? But if you're dealing with some other scenario altogether, you might have a much larger alpha level. Okay, the most common alpha level that is used is the 0.05 alpha level. Okay, and this was from your book talks about why 0.05, why the 5% alpha level became so popular. It goes back to a particular statistician who would, basically generalize and say, if we got this result 1 out of 20 times, that's kind of a threshold, right? If we got it more than 1 out of 20 times, then, we're going to fail to reject. If we got it, 1 or less than 1, then that really makes us suspicious. So 5% is the most common alpha level. The other common alpha levels are 1% and 10%. Okay, but 5% is by far the most popular or most common. Okay, so if you get a p-value, if your p-value returns much smaller, or not doesn't have to be much smaller, but smaller than alpha. So let's say you get a p-value of 1%. Okay, well, what does p-value mean? What does p-value equals 1% mean? It means that if the null hypothesis is true, or given that the null hypothesis is true, we would get a sample result this extreme or more extreme only 1% of the time. Okay, so that gives us reason to doubt the veracity of the H null. Okay, so when p-value comes back small, meaning less than alpha level, okay, then we call those results statistically significant at the alpha level. Okay, those results would be statistically significant at the alpha level. Okay, and in that case, we're going to reject the H null. Okay. So p-value less than alpha, we reject H null, and that provides evidence for HA. And again, that statement's going to be in context. P-value is greater than or equal to your alpha level, we fail to reject H null. This does not provide evidence for HA in context. Okay. All right, so here's an example, better batteries. A company has developed a new deluxe AAA battery that's supposed to last longer than its regular AAA battery. However, these new batteries are more expensive to produce, so the company would like to be convinced that they really do last longer. Based on years of experience, the company knows that its regular AAA batteries last for 30 hours. So that is the true population mean, right? So mu equals 30 of continuous use on average. The company selects an SRS of size n equals 15 new batteries and uses them continuously until they're completely drained. Then obviously they measure like how long, right, did they last. Significance test is performed using the hypotheses. So remember, the null hypothesis is always a statement of no difference. There is no difference. The new batteries are no different than the old batteries, right? So mu equals 30 hours. What is mu? Mu is the population mean for the new batteries. Okay, the new batteries. Okay, we already know that mu equals 30 for the old batteries, but our question of interest is, are the new batteries better than the old batteries? So H null is no better, no different, status quo. Mu is equal to 30. What our sneaking suspicion is, what our hunch is, what we're really hoping to find evidence for, our alternative hypothesis would be a greater than. Okay, it's not a less than, it's not a not equal to. We want to know, is mu greater than 30 hours, all right? Where mu is the true mean lifetime of the new batteries. So let's say we go ahead and do our significance test and we get a resulting p-value of 0.0276. 0.0276. What do we conclude? Well, first of all, before we would gather any data, before we ran any test, we would determine what the alpha level is up front before we calculate a p-value. It's no fair, it's cheating if you calculate the p-value and then set the alpha level. We don't do that. Not only is that wrong, that's cheating, it's unethical. We don't do that, okay? So at the alpha equals 0.05 level, what can we conclude? Well, since our p-value of 0.0276 is less than alpha equals 0.05, what do? Do we reject or fail to reject H null? We reject H null. Okay, that's your first concluding sentence. You're going to have two sentences. Your first sentence is a statement about H null. You either reject or fail to reject. You have to include your p-value, explicitly state what the value is, compare that to the alpha level, okay, and then either reject or fail to reject H null. So our first sentence is, because our p-value of 0.0276 is less than alpha equals 0.05, we reject H null. Okay, that's your first sentence, period. Second sentence is a statement about HA in context. In context. This is strong evidence that the true mean lifetime of the new deluxe AAA batteries at this company is greater than 30 hours. Those are your two sentences. Okay. What conclusion can you make at the alpha equals 0.01 level? Okay, well, it's going to be different than this. Since our p-value of 0.0276 is greater than our alpha level of 0.01, we fail to reject H null. This does not provide evidence that the true mean lifetime of the new deluxe AAA batteries is greater than 30 hours. This is a better way to state it. We do not have enough evidence, or we cannot conclude that the new deluxe AAA batteries last longer than 30 hours. Okay. So your conclusion is always two statements. A statement about comparing the p-value to the alpha level and then rejecting or failing to reject H null. The second sentence is, we have sufficient evidence, or this is strong evidence for, and then HA in context, or we cannot conclude, or we don't have enough evidence, okay, to conclude HA in context. All right, next topic. Is it possible that after doing this test, you make an error? Yes, we know it is. Okay, there's two different types of errors that you can make. There's a type 1 error and a type 2 error. Okay, type 1 error and a type 2 error. A type 1 error is incorrectly rejecting the null. Write that in your notes. Type 1 error, incorrectly reject the null. A type 2 error is we incorrectly fail to reject the null. We incorrectly fail to reject the null. Okay, those of you that are more strong visual learners, copy this table in your notes. Okay, those of you that are not strong visual learners, ignore that table because it will confuse you, and memorize those two phrases that I just told you. A type 1 error, the definition of a type 1 error is that you incorrectly reject the null. A definition of a type 2 error, or the definition of a type 2 error, is you incorrectly fail to reject the null. Okay? So now we need to know what is the probability, how often are we going to commit a type 1 error? Like, how often could that actually happen? Okay? And all you need to do is memorize this. The probability of a type 1 error, okay, the probability of a type 1 error is your alpha level. So if you set alpha is equal to 0.05, the probability of getting a type 1 error is alpha. The probability of getting a type 2 error is equal to the Greek letter beta. Okay, now, can you calculate that beta? Can you calculate that probability? No, you can't. Okay, your calculator can't even calculate it unless you install a program called Type 2, which we don't have access to. You're not ever going to be expected to calculate the probability of a Type 2 error, beta. Okay, but you have to know what beta is. It's the probability of a Type 2 error. The last thing you have to know is what the power of a test is. Like, how sensitive is a power? Like, how often is a test correct? Okay. Power is just 1 minus beta. Excuse me. Power, sorry, scratch that. Power, yeah, sorry. Okay, sorry. Excuse me. So power is 1 minus beta. Power is the probability that you correctly reject H null. That you correctly reject H null. Okay. So it is 1 minus alpha, excuse me, not 1 minus beta, 1 minus alpha. Okay, so power is 1 minus alpha because alpha is the probability of a type 1 error. So the complement of that, okay, 1 minus alpha would be the power. Okay. You also have to think about and interpret consequences of errors. Okay, so here's an example: perfect potatoes. So there's a potato chip manufacturer, and it buys potatoes, right? So its supplier of potatoes, this guy, this farm that grows potatoes, brings this huge truckload of potatoes to the potato chip manufacturer, right? And so, in the end, the potato chip manufacturer is either going to buy this entire truckload of potatoes and make potato chips out of it, or the manufacturer is going to say, you know what, I don't want these potatoes, take them back, I'm not going to purchase them. Okay? And it all depends on how many blemishes that each potato has or the shipment of potato has, right? So if the producer determines that more than 8% of the potatoes have blemishes, the producer is going to say, go back, I'm not going to buy these, I'm going to buy potatoes from a different supplier, right? Otherwise, the entire truckload will be used to make potato chips. So to make the decision, a supervisor will inspect a random sample of potatoes from the shipment. The producer will then perform a significance test using the hypotheses. H null is that P is equal to 0.08. Okay, it's a statement of no difference. Okay, potatoes are fine, we'll take them. HA is the sneaking suspicion of, I think these potatoes might be pretty bad, right? So the true population proportion of potatoes with blemishes is greater than 0.08. So what is a type 1 and a type 2 error in the setting? And think about the consequences. It doesn't tell you the consequences. You have to figure out the consequences. So what's a type 1 error? Well, we said that a type 1 error is incorrectly rejecting the null, incorrectly rejecting the null. So after the test, okay, the producer rejects the null, right? Rejects the null. So it says, nope, I think, I'm going to reject the null in favor of HA. I think that these potatoes are actually really bad. Take them back. I'm not going to purchase them. Okay. What's the consequence of that? Well, this potato chip producer incorrectly rejected the null in favor of the HA. So the potatoes in the truck were actually good. They were good enough. Okay, they met the standard, but this potato chip manufacturer sent the entire truckload away. Well, what's going to happen? Now there could be a delay in the manufacturing process because now you got to wait for a different supplier to come and deliver an entire shipload or truckload shipment of potatoes. And who knows if that, truckload of potatoes is going to meet the standard or not. So there could be potentially lost sales, lost revenue. And now there's going to be distributor shelves with, empty shelves where there's no potato chips there. I went to Safeway the other day. I was looking for a very specific type of potato chip. It's actually not a potato chip, but they're called popcorners. I love popcorners. They didn't have them. They had all sorts of different things, and I looked on the shelves. They didn't have them. Okay, maybe there was a type 1 error at the manufacturing plant. Who knows? Okay. What about a type 2 error? A type 2 error is when the manufacturer in this case would incorrectly fail to reject the null in favor of HA. So that means that the manufacturer said, okay, looks good, I'll take all your potatoes. But that was an incorrect decision. The potatoes are actually bad. So then what's going to happen? That might make consumers very upset because now you're going to be making potato chips where consumers are getting a lot of bad potato chips, right? They're getting the kind of potato chips where you can't eat them because they're all, blemished, right? So that might end up in a loss of reputation, which might have more of a long-term impact on the sales of the company, right? So what are the error probabilities? Well, you can assess these, okay? So assuming that P is equal to 0.08 is true, sorry, that should be an equal sign. The sampling distribution of P hat will be what? Approximately normal, right? Center, the mu of P hat is going to equal, well, P is equal to 0.08. Okay, the spread, so sigma of P hat is going to equal P times Q over N. Okay, and now this P and this Q is different than it's P null and Q null. Okay, so it's assuming, remember this is assuming that H null is true. So which P and which Q do you use? Do you use P hat or Q hat here, or do you use P and Q? No, you use the actual, like, under the null hypothesis. So this is P null, Q null. So under this null hypothesis, you use 0.08, okay, and then 0.92. So the probability of type 1 error is right there. Okay, it is alpha. Okay, so it's 5%. So 5% of the time, okay, or the probability of making a type 1 error is 5%. Okay, what about type 2 errors? So we can calculate the probability that the test does reject H null when an alternative is true. Okay, this probability is called the power of the test against that specific alternative. So the power of the test against a specific alternative is the probability that the test will reject H null at a chosen significance level alpha when the specified alternative value of the parameter is true. Okay. And your power is 1 minus beta. I knew it was 1 minus beta. Why did I say 1 minus alpha? 1 minus beta. I wrote that wrong in my notes. I apologize. Power is equal to 1 minus beta. Okay. 1 minus beta. And by the way, this probability of a type 2 error, if they make you calculate this, they will give you the probability of a type 2 error. Okay. Okay, read the rest of the chapter. Read 11.2, 11.3, and 11.4. They give you some good information in those. And I'll point out a few things point out a few things that I think are really important in those sections. It is definitely worth reading. What I would do is for sure read the part about two-sided tests or two-tailed tests. Example 11.3 is a good example of that, where your alternative hypothesis is going to be a not equal to. It's not going to be less than or greater than, it's just a not equal to. Okay, and there, when you calculate it, what you do is you just calculate the p-value of one of those inequalities, and then you just double it, okay, because it's a two-tailed test. Okay, what else is important? I think that going through example 11.10, 11.10 on page 706 is pretty important. So I'd spend some time going through that example very carefully, particularly the conclusion. Okay. Also understand that a confidence interval, what we did in the previous chapter with confidence intervals, those are kind of like a two-tailed test. There's kind of a relationship between those and a two-tailed hypothesis test, right? Okay, what does it mean if something is statistically significant? It means that it is unlikely to occur simply by chance, right? It's very unlikely to occur simply by chance. Make sure that you understand the definition um, of an alpha level. And this is on page 720. At the very bottom of page 720, there's a quote in the book that I think is really worth your time to memorize. Okay, and it's talking about alpha level, and it says results this extreme, and I'm going to add in or more extreme. So results this extreme or more extreme occur only alpha percent of the time just by chance if H null is true. Okay, so when H null is true, your sample will only return results this extreme or more extreme alpha percent of the time. So not that often, but that really gives you an idea of, well, what is alpha level, right? That really helps you understand that. Then finally, spend some time with type 1 and type 2 errors. Think about the consequences of them. Okay, type 1 error, incorrectly reject the null. Type 2 error, incorrectly fail to reject the null. The probability of a type 1 error is alpha. The probability of a type 2 error is beta. The power of a test is 1 minus beta. Okay. And that's really all you need to know for really all of chapter 11. In the future, I'll make a video where I'll teach you the specific procedures state plan do conclude for the two different types of tests that we're going to do right now, which is a test for mu and a test for p. Okay, thanks guys. See you in the next class or video.